now we will continue by building the glass sim, and then we will build the instancing on top. So let's start with the glass first. So let's dive inside the building glass sim. I'm gonna keep this on maybe manual for the time being. So again, we need to bring in our building caches, so we can, I think, start from this section here by bringing this guy in. Okay, and obviously we're gonna need the controller as well. We forgot that one. Let's get the controller, and also the wedge controller. Let's dive in, paste it back in. Okay, so we're gonna load our buildings here, and this is going to display the wedge based on the value here. So now the other thing we need to do, obviously, is let this load, bring in the glass caches that we originally had, that we've seen at the very beginning of the tutorial almost, in the fracturing. So which means we need to use this value. Okay, let this load in again, sorry, manual. So I'm going to break this link for now, and I'm going to go in here and create another chain for glass sims. So this can be directly after RBD building. So this is the sim, right? So from here we can branch out. So let's create a wedge node. Okay, come on. And let's name this BLDG building glass, BLDG glass. Okay, and for now this is also one, and we're gonna name the attribute as wedge BLDG underscore glass. It's a separate chain, it's an integer, okay, but it goes under this guy. It just needs this to be finished because okay, this is green again because of wedger. So since the sim, I'm gonna copy this guy because that's a sim as well. Remember, all of our simulations needs to be all frames in one batch. I can copy paste this guy here, link it up here, name it wedge BLDG glass sim. Now again, we need to be paying attention to what we're pulling in here. So for now it's empty because we didn't finish the chain yet. And the other thing we're going to change here is the override attribute. Overriding attribute is not wedge building secondary sources here, it's rather wedge building class, right? Frame range is correct, all frames. All right, fair enough. Now let's go back in. Oh, make sure we copied that, right? I got that because I'm gonna use that. And let's go in here again, and this guy, I want this, and I'm just gonna cook it so it does, the variable is set 0 across. Okay, let's just give it a second. It shouldn't take long. It's doing something. Okay, if I select this, turn it off, then the value is declared. We can dive back inside our glass sim here. Okay, now I want to bring in my glass, so I'm going to object merge, drop an object. Oops, I'm going to drop in an object merge here. I'm going to say this in glass. Okay, so you come here, let's pin it, and now let's go to this. Doesn't have to be disabled. Let's go back into our building sim and all the way up. No, it's the fracture, sorry, building fracturing. Nope, it's not building fracturing, it is here. Yes, it's here. My bad. Okay, let's put I guess a null there. glass, so this guy goes up here into this. I think this value is still not same as it was. In this case, yeah, it's we didn't update it, so let's just copy that settings. It's the same. Oh, actually, I think no, because this is going to use a different wedge value, right? It's going to use the new variable, which we updated by copy pasting something else. So go back to here, copy this guy, back in building sim, keep wedge based on this guy. So this should load the glass for the first building. Let's have a look. It's already fractured. Remember, it was quite a few pieces, but we're gonna merge them in based on the expected performance of our machines, basically. So these are the glasses now. So what were we doing here? Just a little reminder. We load in the asset. So we need to chain out here as well. My bad. It needs to be something like this. This needs to come from all the way here. So this needs to be about here. Okay, like this. And this needs to be here as well. Okay, this shouldn't change the result. This should work. Let's load it and then let's see what we're doing. Okay, now this should kind of line up with this guy, I guess. All right. If you template it, right, our glasses are lined up with our simulation object. So what this guy was doing, a bit reminder, here we get our all simulation points. Here I tell them which point to blast because each point represents a building. Here the attributes are loaded, so our point knows what geometry load. It's actually loaded into Houdini using an instance swap. It's fit back using the same values as fit floor. It's unpacked, so Houdini has access to first layer of packed geos, which one of them we named glass during our fracturing workflow, and I'm just blasting everything but glass using a name attribute, matching primitive attribute, which says here RBD type glass equals glass, delete non-selected, so keep glass. Okay, so this is now in simulation world here. Okay, let's keep going. It's what is it, calculating something. All right, load it in. It's going. Okay, this is my glass. Because this level is quite a heavy geo, so we need to do a little cleaning now. So first of all, we need to do an unpack because these are all packed, right? So we need to have access to the geometry itself. So each one of these glass has already a primitive attribute called glass. So there's like quite a few of them. 1,183,778 glass pieces. Okay, so that's a little too much, but that depends if you want it to be too much or not. But because we have the names, we can do an RBD cluster. Okay, so I found out for my CPU, I think size 2 meter by 2 meter by 2 meter was kind of reasonable. I'm turning off the random detach because it detaches from wherever it cares. I'll show you now. Let's do its thing using the name attribute. Now it's going to merge some of these from some closer areas. Okay. And if I do a now exploded view, taking a while. If I do an exploded view here, it's gonna give me, instead of individual connections, it's going to give me, come on, little bigger chunks. So these will be the smallest sizes of the glass I can have. Okay. So I guess 1, 1, 1 would work a bit better, but this is also fine. And if you do detach, why am I not using random detach? Because I would prefer to have some bigger chunks than maybe disconnected edges, but random is just gonna disconnect randomly. Okay, so then you'll have a glass that is flying around with another glass missing in the center. Well, it's not maybe a big deal, but you'll end up with a lot more pieces too. So the size of your cluster determines how fast your simulation will go. Okay. So we need to, because the glass simulation is made out of so many pieces, we'll try to get rid of as much of this G as possible. Because of that, we need to bring in the terrain and get rid of what's stuck inside the land. So let's pin this here. Let's go to terrain. Okay, terrain is here. I'm gonna go out to undestroyed terrain geo here. Go back to where I was. I think I should put this on manual. Okay, so we have our terrain. I'm going to use an extrude volume based on my size. It's gonna need minus 100 meters, can be flattened, and then I'm gonna drop in a VDB from polygons to create a volume out of it with a voxel size of 2. Okay, so this can happen now. Then what I'm going to do is, remember I'm usually using the volume sample. Just going to show another way of doing grouping based on volumes is this guy. You can drop in a group. So under here we can pack our objects, because we have the name attribute. So you do want the name attribute and you want that to be promoted as well. So plug, come on, zoom. Okay, so now this is, oh shoot. Okay, did we save? I hope this is fine now. Okay, part 6, so we should have probably saved. Okay, I loaded the crash file back and it survived. And then I saved this part 7. And let's go auto update and let's hope it won't crash. Waiting for this to go through. Since the wedger didn't run, I think it's gonna default to 0 anyway, which we are working on 0 anyway. And it worked. So from 1 million it worked, but I don't see it. Okay, let's try. I have numbers, so it may be a scene view issue. This is correct, this is correct, this should be still correct. Do not disappear. Okay, so from 1 million pieces to 49,000 pieces for the because we kind of merged them, right? So this shouldn't be a big problem. So let's the last thing we put was the group. I'll name this in ground to determine what's inside the ground. We can use the same name for the group name. We're gonna use points. It's going to be bounds using volume. Okay, and then this guy will go to the right. Needs to calculate what it did there before. Okay, and now if I go here and come here, it should give me some parts selected here. We can blast them away. because we're not going to simulate them. So let's blast them away. Remove inside ground. Okay, maybe it'll save you 10 minutes, maybe it will save you a bit more, but it will save you time. In ground. Notice how I'm copying things before I plug them in, so the recording is slightly shorter. Okay, we got rid of some chunks here. It's what's meant to be underground anyway. So what I want now is kind of do the same thing for my simulation, but we're gonna do it a bit different this time. I'm gonna disable that. I'm gonna disable that as well. Let's pull this guy a bit down here. Let's pull this guy a bit down here. So at the first frame, I have all my particles, right, and my building. So I want to make sure that what is inside the first frame is always outside. So I'm going to put a time shift. Okay, I'm gonna break this. So it's kind of like my rest position for my points. I'm going to do the same thing I did here. So I can just copy this because I'm working on the points still. Okay, if I go here now, it's going to remove all these pieces. So how many pieces is this? Let's see. It's almost like 35,000 pieces to be not needed. Then I'm going to use this one also here on this side. Oops, not this one. Copy good, copy, one not copied, then paste. So second input, first input, okay. So it's going to be removed even if it's live as well, because this is the standard, this is the first frame, this is the rest of the frame. So this then can go in here, so it removes the rest, it removes the main piece geo that is still underground, and then it goes down to transform. Let's leave it there. Now the other thing I want to do is to check what's at the edge of this window, of the frames, right? I want to, because I'm going to use guided geo, but I want the edges to be guided. Okay, so I need, let's see if this is unpacked here, this is unpacked here. Oh, sorry, I don't need this here, this can bypass here. I just need the unpacked at the first frame. So I can go here, this can come here now. This is my unpacked building, right? I'm going to scatter some points here, not some, but quite a lot actually. At this frame, it's not moving anyway. Accelerations go 1 million points. Okay, so because with points I get more resolution than the geo itself, right? Because if I go like, I don't have enough, maybe I don't have enough detail on these frames here, and you can do something like this because we have frames and the glass is only around the frames, so we can just blast. Oops. We can only keep the frames, so we get more space. We get a better distribution on our glass point count. Okay, so we get even more better edge control. Now I want to create an attribute wrangle, and I want to call this f at edge equals 1, frame edge, copy, paste, come over under here, call this edge equals 0, and this is glass edge. Okay, okay, now we're going to do a little attribute transfer. Let me save this. Okay, we're going to transfer from here to here. Remember, these are packed, so we're going to transfer it to the packed object, not the edge of the packed object. What I want to transfer is edge, Oh, should have done that before transferring everything. And my value I want to define to be 0.5, so it's 50 centimeters. Okay, if I put a color swap to see what I am coloring based on attribute, then I should see some coloration at the edges. Oh, do I need to be packed to see if I have some edges here? It's because I need to blast away some of the points. No, not this one. Add. Give it a second. It's hard to see like this. Can I color the primitives instead? Let's try that. But no, it won't work like this. Maybe I'm expecting to see some white edges to the biggest size of the okay, you know what, let's do this and that will work. Let's create an edge group. So let's drop another triangle. That should work. And you want to create a group from a file, from an attribute. There's a drop down on the right side here. There's a nice preset group already. Point group on threshold. So I want to create a glass edge group, which is edge, and then it's also driven by the edge attribute, so it should take care of it. Let it do its thing. So we have an edge of 11,000 points. How interesting. On my other screen it shows us, it shows colored. Here it's not showing colored. Is it because okay, interesting. I don't know. Let's go back to this pack object here and say display as bounding box. Okay, it picks it up here. Okay, maybe it's this size. So I'm going to disable this to show what I'm trying to do, so it gets a bit more granular view. It's going to take a bit longer probably. Okay, so here I have so much more points, right? And you see the red areas, those are the glass that is stuck next to the frame, something like that. Because I want this glass, these red ones, to always follow the geo, and black ones to be the simulated, right? But that's way too many pieces. So that's 1 million, more than 1 million. That's going to be a very long sim. So what I prefer to do is to cluster them, okay, and lesser the amount you go, more unique pieces you'll have. But when you merge them, then kind of it may not be reaching long enough to get the cluster on the edge, because the centroid of the merged piece is now further down, and our distance is limited to 50 centimeters based on our attribute transfer, but this is just fine. Okay, so we have an edge group now. Edge group. This is for telling Bullet Solver to follow. Okay, so I have my driver and collider. Okay, I have my glass grid on the left side. All I need to do is now to drop an RBD Bullet Solver. Okay, these are already packed. So they don't really need the color anymore. This is just for visualization. So starting from 1000, the changes are on solver level, collision, needs to be deforming static object. Okay, on guided, we're going to use guides, obviously, and we're going to use the edge group that we have here. Okay, throughout the entire frame range, we want guide to be continuing. Max distance 1 meter. Strength I put 10, so it kind of like follows really good. Okay, that's the fall off. There's more controls. You can make them kind of come off over time, but because we are really far most of the time and already the action is taking place, we don't need to go extreme. It's just gonna create a bit. It's gonna slow down. So the near surface is using it finds the points to be guided a bit better because it's using a VDB. Let this cook here. What else do we need to do? Oh yeah, we need to plug this guy in, of course, to both guided sim and collision geo, because that's what it is. Let it cook. And collision geo as well. Okay, and finally we do want to capture only the simulated points, so this will be the output. The last output is the simulation points. Name these out glass sim. Okay, now what we want to do is to bring this guy as our simulation object. I'm gonna put this on manual. Let's save this again. Let's go into simulations. So this guy, right? This one here. Pin it. Back into the glass sim. You drop there. You drop there. Okay. Now, once we simulate this, we want to be able to read this back into, to see if things are working. This will be the path. And because of the $os, which we need to put it back here. Okay, so now this should be finding the sim. And finally, what we will do is to transform pieces. That goes here. And that goes here. And this guy will give us the result. So let's cache this out, and I'll make sure that this is set to all frames. All good. Frame range is good. Now let's cache this out and look at the result. And I'm going to do a flip book with all other pieces as well. Okay. Okay, now that's done. Everything else is cooked from before. Let's have a look at our result. We can turn this back on to auto update. So that should now load something. Hopefully. Okay, so these are all at the moment showing as packed, but let's do something like this. Let's go to last frame maybe. Okay, and then we can do pack, edit, and tell it to show us the geo. Okay. And now we're just gonna hope that these flat guys are lined up. They're colliding with the interiors, and the ones that did not break are lining up with the frames. Let's do a merge. Now this is a bit of a slow way to do it, but for visualization, that's fine. Come here. That seems to be the case in most places. Okay, so we have so obviously if you have a smaller RBD cluster, you're gonna have more free glass pieces around. Yeah, can we color this so it makes a bit more sense? Oh, forgot to put a drop there as well. Let's color swap. Let's color these prims. Let's give it a blue so they're glass, right? Okay, and I'll bring you here. You go there. Okay, so these are our glass pieces. The rest is our geo. Some are still stuck, some are not, some are sliding inside, so on and so forth. So yeah, that's gonna work. And I did the flip book as well. I brought the ground, I turned on the ground, just picked a random camera angle, and there's the volume and the particles and the glass and everything. So far that's how it looks. Sparse is doing a wonderful job on the streamers. And our building is going down. We'll probably simulate this another 250 frames, but so far so good. All right, the next thing, so we don't need this here. So one more thing. What we need to do though is, remember how we baked out our buildings just before simulating? We need to bake out our optimized glass grids as well. We don't necessarily have to, but then it would have to calculate each one of these. We can keep it live and we can bake it out from here as well. That will also work, but I'm going to prefer to bake it out. So let's go to here, and I think we did something like rest RBD building. So let's do the same thing. I'm going to copy this guy. And I'm going to say same guy will override it, rest RBD glass. Okay, and this is gonna do only one now because the wedge is set to 1, but the value is written over there. So if I bake this, oh no, sorry, cancel. I need to update the subpath. Pin, stop. Go to glass. I want this guy, right? So out rest glass, out rest glass, goes here. Okay, now I can cook it. Therefore, then I can load it. Okay, so let's cook it. So since now our sim is working, so there are things to do, right? So these guys, some of these guys, you remember they were black, so they're going to be just instances rotating, falling down. You have some sand, dust. That's just going to give a bit more granular resolution to the simulation itself. And basically what you guys need to do is that if you're happy with your results, you need to change that RBD, where is that? Because we simulate all the buildings, but here down we are not simulating everything else, right? So because the value was this, it's basically changing that to 7 and matching this range and cooking everything pretty much under this. Let's put a wait for all here at the end. Wait for all. And then goes here. Oh, we have an error. Let's investigate. It said something didn't work. Unable to open file. It's not finding it. Why? Why is it unable to open? I don't understand. As but it wasn't found. You're not found. It's right. It this guy is overwriting this one here. This one is set to 0. So this should be my output glass result. Okay. And why it's not working? Let's turn this off while debugging. This is a single frame, indeed, correct. There's no $F4 wedge RBD. Is this correct? No, it's not correct. That's why. That will be correct. Hopefully now. Cook, save, continue. Now it should cache out one of that again onto the disk, so we can load it back in every time we want to replace whichever building we want to visualize, right? Because we're gonna do a very similar thing we did for the buildings, how we load back the buildings. We're gonna do the same thing with the glass. Okay, while this is cooking, let's plan the next move. In the next video, we're going to continue building our debris simulation. It's a part of, it's not really a sim because we simmed it here. We're gonna kind of extract the data, make sure it's correct, and then basically keep it alive here. Like, you know, we're gonna split based on the groups because we had 2 of them. If you guys remember, it was in here we had dust and debris, and they come out with those groups. So that's what we're gonna do. We're gonna split them. We're gonna prepare them for ready for extraction. This is still erroring. It still says the same thing. Unable to find. Unable to open file. Am I out of disk space? I don't think so. It's not. Okay, this is not a sim. This doesn't have to be in one batch. Maybe that's why it's erroring. Let's try again. I do have enough disk space. It's not that. And I'll debug it in another video if that doesn't work. So basically this is the part that is the building render. Let's put a geo, say glass render. Oops, the opposite. Glass RBD render. Okay, and one thing I want to check is then to basically do a test render and see if this is all working. And if it's all working, then we're going to take out all our caches and start building our render scene. And I'll see you in the, I think it's not going to error this time. No, it errored again. Okay, I'll investigate this and I'll get back to you in the next video.